It finally moved. That single phrase, whispered in the corners of deep space forums and leaked through raw data pipelines, shouldn't exist. For a decade, Planet 9 has been a ghost, a mathematical haunting of our solar system, predicted by equations, but invisible to our eyes. We've been told to wait for the next great telescope, the next decade, the next generation. But what if the search didn't start with a new lens? What if it ended in an archive from 40 years ago? Somewhere in the cold digital graveyard of a forgotten satellite, 7 pixels of heat were caught where they didn't belong. And when we looked again 23 years later, the heat had shifted. The James Webb Space Telescope is now turning its terrifyingly sharp gaze toward a specific set of coordinates, not because of a guess, but because for the first time in human history, the ghost in the dark has been caught in motion. We aren't just looking for a planet anymore, we are tracking a target. Imagine a cold case that has been frozen for 40 years. In the world of forensic astronomy, the most significant evidence often isn't found by looking at the sky today, but by digging through the layers of noise left behind by the pioneers of the past. Our story begins in 1983 with the launch of the Infrared Astronomical Satellite, or IRAS. This wasn't a telescope designed to see the stars as we do. It was designed to feel their heat. To function in the absolute zero of space, its sensors were cooled with superfluid helium to just 2.5 degrees above absolute zero, allowing it to detect the faint thermal whispers of objects that emit no visible light of their own. During its 10-month mission, IRAS mapped the entire sky, capturing 350,000 infrared sources, everything from distant dust-shrouded galaxies to the rocks drifting in our own backyard. But for decades, the data sat in the archives, a massive mountain of information that was simply too large for any human mind to process. The problem with searching for Planet 9 is a problem of scale. The outer solar system is so vast that even at the speed of light, it would take you 8 hours to reach its edge. We are looking for an object that is likely 5 to 10 times the mass of the Earth, yet it is so far away that the sun would appear as nothing more than a bright star in its sky. In visible light, this world is almost non-existent. Sunlight has to travel out to the planet, bounce off its surface, and travel all the way back to our telescopes. This makes the planet roughly 10,000 times fainter than it would be if it were at the distance of Neptune. But in the infrared, the math changes. A planet's own heat, its thermal radiation, only has to make a one-way trip. This is why the IRAS data was a ticking time bomb of discovery. It didn't need the sun to find Planet 9, it just needed the planet to be warm. For years, the Planet 9 hypothesis was a battle of statistics. Astronomers like Mike Brown and Konstantin Batygin pointed to a clustering of distant icy rocks in the Kuiper Belt, arguing with 99.6% to 99.9% certainty that an invisible giant was herding them like a gravitational shepherd. But critics argued this was nothing more than observational bias, that we only see the clustering because that's where our telescopes happen to look. To break this stalemate, we needed a visual. We needed a Leverrier moment, referring to the mathematician who predicted the position of Neptune using nothing but a pen and paper in 1846. When astronomers pointed their telescopes where he told them to, Neptune was there, within a single degree of his prediction. But Planet 9 has proven to be a much more elusive ghost. Enter a new team of cosmic cold case investigators, led by Terry Fan and Professor Tomo Goto. They didn't build a new telescope, they built a better filter for the old ones. They decided to compare the 1983 IRAS survey with a second all-sky survey taken in 2006 by the Japanese satellite Akari. The strategy was simple but agonizingly tedious. Look for a faint heat source that appeared in the 1983 data and see if it had shifted position by 2006. They were looking for a candidate that moved exactly as a massive distant world should move over a 23-year gap. Out of more than 2 million data points, they filtered out the stationary stars and the distant galaxies until they were left with just 13 possibilities, and then they whittled those down to 1. This is the 7-pixel ghost. In the 1983 IRAS data, there is a tiny cluster of 7 pixels that are just slightly warmer than the vacuum around them. By itself, it looks like noise, a digital hiccup in a 40-year-old sensor. But when the team looked at the same coordinates in the 2006 Akari data, the spot was empty. Instead, 47.5 arc minutes away, a distance equivalent to about 1.5 full moons in our sky, there was a matching heat signature. It had moved. It wasn't a star because stars don't shift that much in 23 years. It wasn't a galaxy because galaxies are stationary on human timescales. It was something within our own solar system, drifting slowly through the dark, exactly where a planet 500 to 700 astronomical units away was predicted to be. The phrase, "it finally moved," began to circulate because this wasn't just another statistical model. It was a physical displacement recorded across 2 different decades by 2 different satellites. However, this discovery created a new, unsettling paradox that the scientific community is currently grappling with. The candidate's orbit appears to have a much steeper inclination than the original models predicted. It is tilted in a way that challenges our current understanding of how the solar system formed. If this really is Planet 9, it isn't just a missing member of the family, it is an interloper, perhaps a stolen world, captured from another star billions of years ago. This is where the James Webb Space Telescope enters the narrative, and where we encounter the blind giant paradox. The public often assumes that because JWST is the most powerful eye ever built, it should have found Planet 9 on day 1. But JWST is a sniper rifle, not a floodlight. It has a tiny field of view, designed to look deep into a single point in space. It cannot scan the thousands of square degrees of the sky where Planet 9 might be hiding. It is effectively blind to the search, unless it is told exactly where to aim. But now, for the first time, we have a tangible suspect. These 7 pixels in the infrared archives have given the giant an objective. As we speak, the data pipelines are being flooded with targeted observations. The internet is rife with claims that the movement has already been confirmed in private NASA circles, fueled by a deep-seated narrative of data suppression. While the official peer-reviewed confirmation is still a slow and agonizing process, the tension has never been higher. We are caught in the gap between a viral certainty and a scientific threshold. We have moved from asking, "Does it exist?" to asking, "Is this it?" The 7-pixel ghost has provided a coordinate, and the most powerful telescope in history is now staring into that specific patch of the void. The ghost in the dark has been given a face, and if the data holds, we are about to witness the moment the most famous mathematical prediction in history becomes a physical reality. But as we look closer at these pixels, we are beginning to realize that movement isn't the only thing this object is doing. Something is happening in the outer reaches of our system, a dynamic, violent shifting of material that suggests Planet 9 isn't just sitting there, it's active, and it's throwing things at us. To understand why the 7-pixel ghost is so terrifying to the scientific establishment, we have to look away from the light and toward the math. Because in the outer solar system, gravity speaks louder than any image ever could. We often think of our solar system as a finished clockwork masterpiece, but the truth is that the gears in the far back are grinding against something massive, something hidden, and something that doesn't belong there. If you were to place a coin on a sheet of paper and suddenly saw it start to move without any visible force, you wouldn't assume the coin had a mind of its own. You would correctly deduce that someone was on the other side of that paper, moving a magnet you couldn't see. This is exactly the situation we find ourselves in today, where the coins are icy worlds the size of cities, and the magnet is a dark giant 5 to 10 times more massive than the Earth. This invisible shepherd has left its fingerprints all over the outer reaches, and those fingerprints are now being measured with a precision that borders on the miraculous. The mystery began not with a visual discovery, but with a growing sense of orbital unease among the Kuiper Belt objects, or TNOs, the frozen relics left over from the dawn of our solar system. For billions of years, these objects should have been scattered randomly, their paths pointing in every conceivable direction like a handful of rocks thrown into an open field. But in 2016, Caltech astronomers Mike Brown and Konstantin Batygin realized that the most distant of these rocks were not random at all. They were all huddled together, their elongated orbits pointing in the same direction and tilted at the same bizarre angle away from the main plane of the solar system. The mathematical probability of this clustering happening by pure chance was calculated to be just 0.4%, which left scientists with a staggering 99.6% confidence that a single massive object was herding them like a gravitational sheepdog. But Planet 9 is not a gentle shepherd. It is a cosmic disruptor that is actively twisting the very fabric of our solar neighborhood. One of the most haunting pieces of evidence for its existence is the fact that it doesn't just cluster orbits, it actively flips them on their sides. In a stable, predictable solar system, you should never find objects orbiting the sun perpendicular to the planets. Yet we see them, ghostly rocks moving the wrong way or at impossible angles that defy every classical model we have. This phenomenon is driven by a complex gravitational dance known as the Lidov-Kozai mechanism, where a distant massive perturber forces smaller objects to trade their orbital tilt for eccentricity in a rhythmic, eons-long cycle. Planet 9 is essentially playing a game of cosmic cat's cradle with the outer solar system, pulling strings that we are only now beginning to see. Even the sun itself hasn't escaped the influence of this dark interloper. For decades, astronomers were puzzled by a 6-degree tilt in the sun's equator relative to the orbital plane of the major planets. While it seems like a small discrepancy, in the physics of a forming star system, that tilt is a massive anomaly that requires a colossal amount of leverage to achieve. The presence of Planet 9, with its vast tilted and highly elliptical orbit, provides exactly that leverage, acting as a heavy counterweight that has slowly tugged the entire solar system out of alignment over the last 4 billion years. We are essentially living in a house that has been slightly slanted by the weight of a giant sitting on the roof. But perhaps the most chilling evidence, the new lore that competitor documentaries have overlooked, is the river of shadows. New simulations suggest that if Planet 9 is out there, it isn't just sitting in the dark, it is actively jamming material into the inner solar system right now. There is a continuous flux of icy bodies being caught in a gravitational game of catch between Planet 9 and Neptune. Planet 9 reaches into the Oort cloud, grabs these frozen wanderers, and flings them inward past Neptune's orbit at a rate that simply shouldn't happen in a quiet solar system. When scientists compared the real-world orbits of 29 recently discovered Neptune-crossing objects to their simulations, the results were definitive. The solar system without Planet 9 was rejected at a 5 sigma confidence level. In the world of science, 5 sigma is the gold standard. It means there is only a 1 in 3.5 million chance that these observations are a fluke. The math is no longer just suggesting a planet. It is demanding Chen 1. This brings us to a terrifying question about the origin of this invisible shepherd. Where did this monster come from? The blind giant we are tracking is a super-Earth, a type of planet 5 to 10 times the mass of our own world. These are the most common planets in the galaxy, yet our own system is conspicuously missing one, unless of course Planet 9 is that missing piece. One theory, the rejected core hypothesis, suggests that Planet 9 was once destined to be a great gas giant like Jupiter or Saturn, but in the chaotic cosmic pinball of the early solar system, it was bullied by the other giants and kicked out into the frozen wilderness before it could finish forming. It is the black sheep of the family, a world that was exiled to the dark and has been nursing a gravitational grudge for billions of years. However, there is an even more unsettling possibility found in the captured rogue theory. Our sun was not born alone. It was birthed in a dense cluster of sibling stars. In those early crowded days, star systems frequently brushed against one another, and in the chaos, planets could be stolen or traded like cards in a deck. This would mean Planet 9 isn't even a native of our system. It is a cosmic immigrant, an alien world from a different star that was snatched by the sun's gravity 4.5 billion years ago. This would explain why its orbit is so radically different, so tilted, and so detached from the rest of the planetary family. We might be sharing our home with a stranger from across the galaxy. As the James Webb Space Telescope begins to probe the coordinates suggested by the 7-pixel ghost, we are forced to confront the reality of the invisible shepherd. We have moved past the era of what if and into the era of where. The clustering is real, the inclination is real, and the river of material being thrown at us is real. Every time we run the numbers, the shadow of a 9th planet grows darker and more defined. We are looking for a world that has been hiding in plain sight, a world that has already dictated the history of our solar system from the shadows. But as we prepare to finally see it, we must ask ourselves, if the math was right about the planet's existence, what else might it be right about? Because some of the most obscure theories suggest that Planet 9 isn't just a planet at all, and that its movement might be the herald of something far more exotic. If you were to walk into a grand library and find thousands of books, all neatly categorized by size and genre, you would eventually notice a pattern. You would see the small, thin poetry books on one shelf and the massive, multi-volume encyclopedias on another. But if you looked closer, you might realize that in this specific library, our solar system, an entire category of literature is missing. There are no mid-sized novels. There is nothing between the pocket-sized paperbacks and the giant coffee table books. In the language of astronomy, this is the mass gap, and it is the greatest architectural flaw in our understanding of our own home. We have small, rocky worlds like Earth and Venus, and then we have a staggering leap to the gas giants. Earth is one Earth mass. Neptune, the next step up, is 17. In that massive gulf between 1 and 17, there is a hollow silence. Everywhere else we look in the galaxy, that gap is filled with super-Earths, planets 5 to 10 times the mass of our own. These worlds are the standard outcome of planet formation, the most common type of planet in the universe, yet they are conspicuously absent from our backyard. Or so we thought. Planet 9 is the solar system's black sheep, a super-Earth that shouldn't be a mystery, yet it has spent billions of years in a self-imposed exile. When we talk about Planet 9 having a mass of 5 to 10 times that of Earth, we aren't just giving you a number, we are describing a cosmic anomaly. If the solar system were a family, Planet 9 is the child that was kicked out of the house before the family portrait was taken. The leading theory among researchers like Konstantin Batygin is that this world is a rejected core. It was never supposed to be out there in the freezing dark 500 astronomical units away. It likely began its life in the inner circle, right alongside Jupiter, Saturn, Uranus, and Neptune, during the frantic, violent first few million years of the solar system's birth. Back then, the solar system was not a stable clockwork mechanism. It was a shooting gallery, a game of cosmic pinball. As the giant planets moved and migrated, their massive gravitational fields acted like invisible flails, swinging at everything in their path. Planet 9 was likely caught in the middle of this giant-on-giant violence. It was a core that was trying to grow, trying to gather gas and dust to become a true giant, but it was bullied. One close encounter with a young Jupiter or a migrating Saturn would have been enough to sling this 5 Earth mass world outward with terrifying speed. It was essentially ejected, tossed into the wilderness like a piece of cosmic trash that the giants didn't want to deal with. This creates a haunting narrative for the search. We aren't looking for a new discovery in the traditional sense. We are looking for a piece of our own history that we tried to throw away. The reason we call it a black sheep is because its very existence challenges the neatness of our 8-planet model. For over a century, we've lived in a system that seemed complete after the discovery of Neptune. We convinced ourselves that the layout of our world was the blueprint for the rest of the galaxy. But as the James Webb Space Telescope and other modern surveys have peered into distant star systems, they've shown us that we are the weird ones. Most star systems have a super-Earth or a mini-Neptune orbiting close to their suns. Our lack of such a world was a mystery that felt like a missing limb. Finding Planet 9 would be the ultimate act of cosmic reconciliation. It would mean our solar system isn't an oddball. It's just a system with a very dark, very distant secret. But why is a world of this specific mass, this perfect 5 to 10 Earth mass range, so incredibly difficult to find? The answer lies in the physics of light and heat. In the visible spectrum, a world at 500 astronomical units is a nightmare to detect because sunlight has to make a round trip. By the time those photons travel out to Planet 9 and bounce back to our telescopes on Earth, they are so diffuse and weak that the planet appears 10,000 times fainter than it would if it were at the distance of Neptune. It is effectively invisible to the floodlight approach of traditional astronomy. However, a planet of 5 to 10 Earth masses is a different beast in the infrared. Because it is massive, it still retains a significant amount of internal heat from its formation 4.5 billion years ago. It isn't just a cold rock. It is a warm, glowing ember in a freezer. This is the core of the 7-pixel ghost mystery. In infrared light, the planet doesn't need to reflect sunlight. It only has to glow with its own thermal radiation, which only has to make a one-way trip to our sensors. In this light, the planet is only about 100 times fainter than Neptune, rather than 10,000. This is why the archival data from IRAS and Akari is so vital. It captures the planet not as a reflected speck, but as a heat source, a black body radiating in the dark. The solar system's black sheep also forces us to reconsider the empty room paradox. For decades, we looked past Neptune and saw nothing but the small, icy debris of the Kuiper Belt. We asked ourselves why the outer solar system was so empty. We assumed that because we couldn't see anything, there was nothing. But volume is a deceptive thing in space. As you go 10 times further out, the volume of space you have to search increases by a factor of 1,000. There is enough room in the outer solar system to hide almost anything you want: big planets, small planets, or even darker things. We have been like people standing in a massive dark warehouse with a tiny flashlight, claiming the room is empty because we haven't hit a wall yet. Planet 9, if it is this missing super-Earth, represents a standard outcome that has been waiting for us in the shadows. It is a world that likely has a thick gaseous atmosphere, a mini Neptune or a rocky core wrapped in hydrogen and helium. From its surface, the sun would be nothing more than an exceptionally bright star, providing about as much light as a full moon provides on Earth. It is a world of eternal twilight, a place where the concept of day and night has almost no meaning. And yet this rejected world is the one that has been subtly pulling the strings of every other object in the outer system, tilting the sun, herding the Kuiper Belt, and flinging icy material toward us in a river of shadows. The most unsettling part of this black sheep narrative is the realization that we might have stolen it. While the rejected core theory suggests it's a native that was exiled, the captured rogue theory suggests that our sun acted like a cosmic thief. In the early crowded cluster where our sun was born, star systems were constantly brushing against one another. In those close encounters, gravity acts like a magnet being dragged through a tray of iron filings. If a passing star had a super-Earth on a wide orbit, our sun's massive gravity could have simply snatched it away. This would mean that the missing stair in our solar system's architecture wasn't missing at all. We just went out and stole a stair from the neighbor's house and put it in the attic where no one would see it. This possibility changes the stakes of the James Webb search. If Planet 9 is a captured rogue, its chemical composition will be alien. It won't match the recipe of the rest of our planets. It would be our first direct access to a world from another star system, a laboratory for interstellar planetary science parked right in our own backyard. This is why the movement detected in the archives has caused such a stir. We aren't just looking for another planet. We are looking for a potential alien world that has been living with us for 4 billion years. As we move deeper into the hunt, the identity of this black sheep becomes the central question. Is it the rejected child of our own sun, or an immigrant from a distant star? Either way, its mass, that crucial 5 to 10 Earth mass signature, is the smoking gun. It is the one thing we can't ignore, the one thing the math won't let us forget. The solar system's architecture is incomplete without it. We have been living in a house with a missing room, and we are finally realizing that the door has been locked from the outside this entire time. The 7-pixel ghost may be the first turn of the key, revealing that the most common type of planet in the galaxy isn't missing from our system. It's just been waiting for us to stop being blind to the heat in the dark. What is the primordial black hole theory for Planet 9? Tell me more about the Vera Rubin Observatory's hunt. How could we have stolen a planet from another star? Continue to Chapter 4 with 2,000 words. When we look at a map of the solar system in a textbook, we see a series of static concentric circles, perfect frozen paths where every planet knows its place. It feels safe, it feels finished. We've been taught that the outer solar system, the space beyond Neptune, is a vast, lonely graveyard of frozen relics, drifting in a permanent, silent slumber. But the most recent data suggests that our map is a lie. The outer solar system isn't a graveyard, it is a loading dock. There is a river of shadows currently flowing through our cosmic backyard, a continuous violent flux of icy material being jammed into the inner solar system from the darkness. This isn't a theory about what happened 4 billion years ago. This is happening right now at this very second. And the only thing that can explain this relentless assault on our stability is the presence of an active gravitational interloper. We are beginning to realize that Planet 9 isn't just a distant ghost. It is a cosmic archer, and we are standing in the middle of its target range. To understand the river of shadows, we first have to look at the security guard of our solar system, Neptune. For over a century, we viewed Neptune as the final gatekeeper. Its massive gravity acts like a centrifugal broom, sweeping the outer reaches clean. Any small, icy object that wanders too close to Neptune gets caught in its gravitational grip and is either swallowed up or, more likely, ejected, flung out into the deep Kuiper belt, or expelled from the solar system entirely. In a normal version of our solar system, the space between Jupiter and Neptune should be relatively clear of these wanderers. Without a replenishment source, Neptune would have finished its cleaning job eons ago. But when astronomers look at that region today, they don't see an empty void. They see a bustling corridor of debris that simply shouldn't be there. This is the inward flux mystery. There is a constant stream of objects crossing Neptune's orbit, moving from the outer dark toward the inner planets. If you think of the solar system as a walled city, Neptune is the wall, but someone is throwing rocks over that wall. For years, scientists assumed these were just random intruders, eccentric comets, or outliers that somehow escaped the Oort cloud by chance. But when Konstantin Batygin and his team at Caltech ran the most sophisticated simulations in history, the math revealed a shocking discrepancy. In a solar system with only 8 planets, the number of objects crossing Neptune's orbit should be almost negligible, roughly 0.5% of the total population of the outer belt. But the actual observations don't match that 0.5%. They show a population closer to 3%. That difference, that extra 2.5%, is the smoking gun. It represents a river of material that is being systematically jammed into the inner solar system by an external force. This is where the game of catch begins. Imagine Planet 9 sitting 500 astronomical units away, deep in the Oort cloud. Its gravity is so powerful that it reaches into the reservoir of billions of frozen comets and yanks them out of their stable orbits. It doesn't just pull them, it slingshots them. It sends them hurtling inward, past the guard towers of Neptune. Neptune then catches these objects, tugs on them further, and sends them even deeper into the system toward Jupiter. It is a tag-team gravitational maneuver that keeps the inner solar system continuously replenished with icy debris. Planet 9 is the pitcher, and Neptune is the catcher. The weight of this discovery cannot be overstated. In 2024, researchers identified 29 specific objects, small frozen worlds, that are currently on these impossible Neptune crossing paths. When these 29 orbits were compared against the 2 competing models, one solar system with Planet 9 and one without, the result was staggering. The solar system without Planet 9 was rejected at a 5 sigma confidence level. In the world of high-level physics, 5 sigma is the ultimate threshold. It is the gold standard of proof used to confirm the existence of the Higgs boson. It means there is only a 1 in 3.5 million chance that these 29 objects are a coincidence. It is the mathematical equivalent of finding a fingerprint at a crime scene that matches a suspect with absolute certainty. The River of Shadows isn't a suggestion, it's a physical reality that demands a ninth planet to exist. This changes the entire narrative of the search. Most documentaries frame Planet 9 as a hidden world, something we are trying to find because we are curious. But the River of Shadows frames it as a matter of planetary dynamics. We aren't just looking for a new point of light. We are looking for the reason why the outer solar system is currently leaking into the inner system. We are tracking a dynamic process that is actively reshaping the environment we live in. Every time a new Neptune crosser is discovered, it's another drop of water in the river and another piece of evidence that the ghost in the dark is very much alive. But why has this been so hard for the public to grasp? Because we have been suffering from a static bias. We are used to things in space moving so slowly that they appear stationary. But the movement we are talking about with Planet 9 is a multi-generational, eons-long tug of war. The River of Shadows is a slow-motion avalanche. Planet 9 has been herding these objects for 4 billion years. But because our telescopes have only been powerful enough to see the small stuff for the last 30 years, we are only now seeing the flow. We are like someone who just walked into a room and noticed a leak in the ceiling. We don't see the water moving, but we see the puddle on the floor getting bigger. The 29 objects we found are that puddle. The lore vault suggests that this River of Shadows narrative is the key to creating a superior documentary, because it introduces a sense of ongoing, active mystery. It's not just, is there a planet? It's, what is the planet doing to us right now? This inward flux of material has profound implications for the history of Earth. If Planet 9 is constantly flinging material inward, it means it has been the primary architect of the comet impacts that have shaped our planet's history. It might have been the hand that delivered the water to our oceans, or the hand that sent the extinction-level event that wiped out the dinosaurs. We aren't just looking for a neighbor, we are looking for the primary engine of chaos in our solar system. This brings us back to the "it finally moved" claim. While the phrase often refers to the 7 pixels in the infrared archives, it takes on a deeper meaning when applied to the River of Shadows. The data has moved. We have transitioned from a phase of statistical alignment, where we just noticed things were clumped together, to a phase of dynamic confirmation, where we are watching the planet actively work. We are seeing the objects it has touched, the orbits it has twisted, and the debris it is currently throwing past Neptune. As the James Webb Space Telescope prepares to zoom in on the coordinates provided by the 7-pixel ghost, it is doing so with the knowledge that it isn't just looking for a stationary rock, it is looking for the source of the river, it is looking for the archer in the dark. The search has moved from a cold case to an active pursuit. We are no longer just measuring the shadow, we are tracking the beast that is casting it. And as we look closer at this river, we are starting to see something even more unsettling. The objects being thrown inward aren't just random. They are moving in patterns that suggest Planet 9's gravity is even more complex than our first models predicted. It isn't just a planet, it's a system, a world that likely has its own collection of moons, its own miniature solar system drifting through the void. The River of Shadows is the ultimate bridge between the math of Caltech and the mystery of the deep archives. It proves that the solar system is not a closed circuit. We are connected to the deep dark by a thread of gravity and a stream of frozen ice. We are living in the wake of a giant, and the ripples of its movement are finally reaching our shores. But as we prepare to see the giant itself, we have to confront the blind giant paradox. Because while we know the river is there, and we know who is causing it, our most powerful tool, the James Webb, is currently looking at the universe through a straw. We have the proof, we have the coordinates, and we have the motive. But in the next chapter, we will see why the most powerful eye ever built might still be looking in the wrong direction, and why the ultimate discovery might not come from a new image, but from an old secret hidden in the way the light itself is being bent. The James Webb Space Telescope was heralded as the ultimate planet hunter, a $10 billion golden eye capable of peering through the dust of the early universe to see the very first stars ignite in the dark. When it launched, the collective expectation was that our own solar system would finally be laid bare, its final secrets revealed by a machine so sensitive it could detect the heat of a single candle on the moon. We can see galaxies 13 billion light years away, stretching back to the dawn of time, and we can map the chemical composition of atmospheres on worlds orbiting distant suns. Yet here we are, caught in a maddening paradox. We can see the beginning of the universe, but we cannot see a giant planet in our own backyard. This is the blind giant paradox, and it is the most frustrating hurdle in the history of modern astronomy. To understand why the world's most powerful telescope is currently failing to find Planet 9, you have to understand the difference between power and perspective. The James Webb is not a survey telescope. It is a high-powered snipe tool. Imagine standing in the middle of a pitch-black cathedral that is miles wide and miles high. You are holding a high-powered laser pointer. The laser is incredibly bright. If it hits a tiny speck of dust on the far wall, you will see it with crystal clarity, but the beam is only a fraction of an inch wide. To find a single specific diamond hidden somewhere in that cathedral, you would have to sweep that tiny beam back and forth for 1,000 years. This is the straw through which Webb looks at the universe. Planet 9's possible location isn't a single point. It is a search zone, spanning thousands of square degrees of the sky. Webb's field of view is so small that it would take decades of continuous observation just to scan the areas where the math says the planet might be. In the cold language of orbital mechanics, we have the orbit, but we do not have the position. We know the path the ghost takes, but we don't know where it is on that path. And since that path takes 10 to 20,000 years to complete, the margin of error is vast. This technical limitation has birthed one of the most persistent and unsettling theories in the lore vault of the internet. The idea that the James Webb has already found it, and we just don't know it yet. This isn't just a conspiracy theory, it's a data processing reality. Every hour that Webb spends staring at distant galaxies, it is also capturing everything that lies in the foreground. Its deep space images are cluttered with billions of bits of information, faint stars, distant asteroids, and brown dwarfs. The theory suggests that Planet 9 is already sitting in a raw data file on a NASA server, recorded as a dim, reddish dot in the background of a study about the early universe. It is hidden in plain sight, waiting for an AI algorithm or a meticulous graduate student to notice that one specific dot moved between two different exposures taken months apart. The search for Planet 9 with Webb is a battle against noise. Because the telescope is so sensitive, it sees too much. It detects the faint infrared glow of millions of objects that are essentially irrelevant to the search, creating a digital fog. To find the planet, astronomers have to perform a process called stacking, where they take multiple long exposure images of the same patch of sky and digitally overlay them. Moving objects like a planet will shift between the frames, while the static stars stay in place. But at 500 astronomical units away, Planet 9 moves with agonizing slowness. In a single night, its displacement is almost imperceptible. You have to wait months, sometimes years, to see the ghosts step out from behind a star. The infrared capabilities of Webb are specifically tuned to the language of Planet 9. Because the planet is 5 to 10 times the mass of Earth, it is a warm object in a very cold place. It radiates heat in the mid-infrared spectrum, the exact wavelengths that Webb was designed to master. If we pointed Webb at the right coordinates, Planet 9 would shine like a beacon. It wouldn't be a fuzzy smudge, it would be a clear, distinct world, potentially revealing the signatures of methane, water vapor, or even a system of moons caught in its gravitational grip. But until the Vera Rubin Observatory or a cosmic cold case team like Terry Fans provides a pinpoint coordinate, the golden eye remains a blind giant, staring past the mystery into the infinite distance. There is a certain eerie beauty to this frustration. We are living in an era where our technology has outpaced our roadmap. We have built the ultimate tool, but we are still drawing the map to tell it where to look. The blind giant paradox serves as a humbling reminder of the sheer scale of our solar system. We often feel like we've conquered our local neighborhood, but beyond Neptune, the darkness is so vast that a world 10 times the size of our own can simply vanish. The internet lore surrounding data suppression also feeds on this gap. Because NASA and other institutions are slow to release raw data that hasn't been peer-reviewed, the silence is often interpreted by the public as secrecy. There is a fear that the discovery of a 9th planet would be too big for a sudden announcement, that it would require months of verification to ensure it isn't a primordial black hole or a misidentified brown dwarf. This delay creates a vacuum that is filled by viral videos and leaked infrared pulses that are usually nothing more than digital artifacts or sensor glare. Yet the possibility remains. What if the "it finally moved" claim is true? What if the 7-pixel ghost from the 1983 archives has been cross-referenced with a modern JWST deep field image? If an AI scanning through the petabytes of public data found that the heat signature from 1983 and 2006 has shifted again into a 2024 Webb frame, the search is over. We wouldn't be waiting for a new telescope. We would simply be waiting for the download to finish. The James Webb Space Telescope is the reason the stakes are so high. It is the only machine currently in existence that can turn a mathematical maybe into a physical here. It can see the texture of the clouds on a world 500 units away. It can tell us if Planet 9 is a rocky super-Earth or a mini Neptune wrapped in a blue-tinted shroud of hydrogen. It is the judge and the jury of this celestial trial. But for now, the giant is looking through its straw, focused on the birth of the first galaxies, while a massive dark world silently drifts through its periphery, waiting for us to finally realize that we've already taken its picture. The mystery of Webb's blindness is actually the final clue in our investigation. It forces us to look at the where rather than the how. It highlights the importance of the river of shadows and the invisible shepherd, because those mathematical fingerprints are the only things that can steer the golden eye toward the truth. We are currently in the most agonizing phase of the hunt. We have the eyes, we have the proof, and we have the motive. All we are missing is the moment the giant finally blinks and sees what has been standing in front of it for 4 billion years. As we move toward the next chapter of this documentary, we must go deeper into the exotic possibilities. Because if the James Webb is looking at the right coordinates and seeing nothing, it means Planet 9 isn't a planet at all. It means the 7-pixel ghost isn't a world of ice and gas, but something far denser, far darker, and far more ancient. If Webb is blind to the light, it might be because there is no light to see. We might not be looking for a planet, We might be looking for a hole in the universe itself. For billions of years, we have lived under the comforting assumption that our solar system is a closed loop, a sovereign family of worlds born from the same cloud of gas and dust, all sharing the same DNA, all bound to the same destiny. We look at the planets and see a family tree with a single clear trunk. But families have secrets. Sometimes a child isn't who you think they are. Sometimes the most massive object in your own backyard is actually a stranger. This is the captured king theory, and it is the most unsettling explanation for why Planet 9 exists where it does. It suggests that we are not alone in this house, that the invisible giant herding the Kuiper Belt isn't a native of our sun, but a cosmic immigrant, a stolen world, an alien interloper that was snatched from another star in a moment of celestial kidnapping 4.5 billion years ago. To understand how the sun could steal a planet, we have to travel back to a time before the Earth was even a solid rock. Our sun was not born in the lonely, isolated patch of the galaxy we inhabit today. It was born in a stellar nursery, a dense, chaotic cluster of thousands of sibling stars, all huddled together in a massive cloud of glowing gas. In those early days, the distances between stars were not measured in light years, but in astronomical units. Star systems were so close that their outer edges frequently brushed against one another. Imagine a crowded ballroom where every dancer is dragging a long, flowing silk veil behind them. As they spin, the veils tangle. In this cosmic dance, the veils are the gravitational fields of the stars, and the threads are the planets still trying to find their footing in the dark. In this crowded nursery, planetary systems were not stable, they were liquid. As a sibling star brushed past our young sun, its gravity would have acted like a massive hook. If that passing star had a super-Earth, a world 5 to 10 times the mass of our own, orbiting in its outer reaches, our sun's gravity could have reached out and snatched it. This wasn't a violent collision, it was a silent gravitational transition. One moment, Planet 9 was orbiting a different sun, perhaps a red dwarf or a bright blue giant. The next, it was caught in the sun's grip, pulled into a wide, elliptical, and highly inclined path that it has followed ever since. We are living with a captured king, a world that was born under a different light and carries the chemical signature of a different star. This theory explains the impossible orbit that has baffled astronomers for a decade. Most of the planets in our system orbit in a flat, neat disk, like grooves on a record. But the math for Planet 9 tells a different story. Its orbit is tilted at a staggering 30 degrees relative to the rest of the planets, and it is detached. It never comes close enough to Neptune to be influenced by the gas giants, yet it is too far away to have formed from the sun's original protoplanetary disk. In the rejected core theory, we struggle to explain how a planet could be kicked so far out and yet remain bound to the sun. But in the captured rogue model, the orbit makes perfect sense. It is the orbit of a prisoner. It is the path of an object that was dropped into our system from the outside, falling into the sun's gravity well at a bizarre angle, and never finding its way back to the flat plane where the rest of us live. But the captured king narrative introduces a new, even more profound mystery: the mystery of the alien recipe. Every planet in our solar system, from the iron-rich core of Mercury to the methane-soaked clouds of Neptune, was cooked from the same ingredients found in the sun's original nebula. We share the same isotopic ratios, the same chemical fingerprints. But if Planet 9 is a captured rogue, it is made of a different recipe entirely. Its water might have different ratios of deuterium. Its rocks might contain elements in proportions that shouldn't exist in our system. When the James Webb Space Telescope finally resolves the light of this world, it won't just be looking at a new planet, it will be performing the first ever interstellar autopsy. We will be looking at the atmospheric chemistry of a world from another star system, parked right here in our own backyard. This is why we call it the King. It rules a domain that the sun barely touches. Out at 500 to 700 astronomical units, the sun is just a bright star, providing almost no heat and very little light. In this frozen kingdom, Planet 9 is the undisputed sovereign. It commands the river of shadows, flinging icy debris toward the inner planets like a king throwing scraps to the peasants. It herds the detached objects like Sedna, keeping them in a permanent gravitational alignment that serves as its own silent manifesto. It is a world that has its own history, its own moons, and perhaps its own miniature solar system of captured rocks, all orbiting a world that never belonged here to begin with. The captured king theory also forces us to confront the stolen stare paradox. For over a century, we believed our solar system's architecture was a masterpiece of internal evolution. We thought every stair in the planetary ladder was built by the sun. But if Planet 9 is a rogue, it means our house is built with stolen parts. We are not a pure system. We are a collection of cosmic fragments, a patchwork family of native worlds and stolen giants. This changes the stakes of the search from a simple discovery to an act of cosmic archaeology. We are trying to find the one object in our system that doesn't fit, the black sheep that was kidnapped from a star that might have died billions of years ago. As we look at the 7-pixel ghost in the infrared archives, the captured king theory adds a layer of eerie significance to every movement. If those pixels represent a stolen world, then every arc minute of movement we track is the movement of an alien entity. We aren't just looking for a 9th planet. We are looking for the first exoplanet we can actually reach. We are tracking a target that was formed in the glow of a different star, a world that has spent 4 billion years in a dark, cold exile, ruling over a graveyard of frozen ice. The James Webb Space Telescope, with its ability to peer into the mid-infrared, is the only tool that can see the king's crown. It can detect the heat of a world that is still glowing from its birth in a different star system. It can see the alien fingerprints in the atmosphere. And as it turns its gaze toward the coordinates in the southern sky, we are forced to ask ourselves, are we ready to meet the stranger? Are we ready to admit that the invisible shepherd herding our outer reaches is an immigrant from the deep galaxy? The search for Planet 9 has always been a hunt for a shadow, but the captured king theory gives that shadow a history. It turns a mathematical anomaly into a story of survival and theft. It suggests that the solar system isn't a closed circle, but a crossroads, a place where paths intersect and worlds are traded. Planet 9 is the ultimate proof that the universe is a fluid, violent, and unpredictable place. It is the king of the outer dark, a silent ruler that has been watching us from its tilted throne for eons, waiting for us to finally look up and recognize that we are not as alone as we thought. We have a neighbor, but it isn't one of us. It is a guest that never left, a prisoner that became a king, and a ghost that has finally, after 4 billion years, begun to move. But as we delve deeper into the origins of this king, we find ourselves facing a final darker question. If the captured king theory explains the gravity and the 7-pixel ghost explains the heat, why is the most powerful telescope in history still struggling to see its face? The answer might not lie in the planet's origin, but in its physical nature, because some of the most obscure data suggests that the king isn't a world of rock and gas at all. It might be something far more exotic, something that doesn't reflect light, because it's designed to swallow it. In the next chapter, we will look at the theory that turns this planet hunt into a hunt for a hole in the universe itself, the primordial black hole. What if the reason we can't find Planet 9 isn't because it's too far away, but because we are looking for the wrong state of matter? For a decade, we have been obsessed with the image of a world, a sphere of ice, a core of rock, a thick blanket of gas. We've looked for the reflection of the sun and the faint thermal glow of a cooling planet. But as the blind giant of the James Webb Space Telescope stares into the specific coordinates provided by the 7-pixel ghost and finds only the cold, unblinking void, a more terrifying possibility is beginning to move from the fringes of theoretical physics into the mainstream. It's a theory that explains every gravitational anomaly, every tilted orbit, and every impossible clustering of objects, while simultaneously explaining why the most powerful telescopes ever built are effectively looking at nothing. What if the invisible shepherd herding our solar system isn't a planet at all? What if it's a hole, a puncture in the fabric of reality no larger than a grapefruit, but with the mass of 5 to 10 Earths? This is the primordial black hole hypothesis, and it suggests that we aren't hunting for a new world, but for a dark, ancient singularity that has been hiding in our backyard since the dawn of time. In 2019, two physicists, Jakob Schultz and James Unwin, published a paper that sent a shiver through the astronomical community. They looked at the same data that Mike Brown and Konstantin Batygin used to predict Planet 9, the clustering of the Kuiper Belt, the tilted orbits of the TNOs, and they asked a radical question. Does the math require a planet, or does it just require mass? Gravity is blind to composition. A 5 Earth mass planet and a 5 Earth mass black hole exert the exact same pull on their surroundings. The only difference is the volume that mass occupies. While a planet would be roughly 2 to 4 times the size of Earth, a black hole with that same mass would be compressed into a sphere just 10 centimeters wide. You could hold the entire gravitational engine of our outer solar system in the palms of your hands, yet it would have enough power to tilt the sun and throw icy worlds across the void like pebbles. This isn't a stellar mass black hole, the kind that forms when a giant star dies and collapses. Those are massive, typically starting at 3 times the mass of our sun. A stellar mass black hole in our solar system would have swallowed us billions of years ago. What Schultz and Unwin are talking about is something far more exotic and far more ancient, a primordial black hole. These are theoretical remnants from the very first seconds of the Big Bang, formed not from collapsing stars, but from the raw, high-pressure density of the infant universe itself. In those first moments of creation, certain pockets of space were so dense that they collapsed directly into tiny singularities. These gravitational seeds have been drifting through the galaxy for 13.8 billion years, and the theory suggests that as our sun moved through its birth cluster, it didn't just capture a king or reject a black sheep, it snared a piece of the Big Bang itself. This grapefruit in the dark explains the blind giant paradox with chilling efficiency. If Planet 9 is a primordial black hole, it would be almost impossible to see with any conventional telescope. It would reflect 0 sunlight. It would have no planetary surface to emit a standard thermal signature. It would be a perfect dark sphere, invisible against the black backdrop of the deep Oort cloud. When we talk about the 7-pixel ghost found in the archival data, the black hole theory provides a much more violent interpretation. A black hole wouldn't glow from internal heat like a planet. Instead, it would glow from a feast. As it drifts through the Kuiper Belt, its intense gravity would occasionally snag small particles of dust, gas, or even dark matter. As this material is accelerated toward the event horizon, it would heat up and release a tiny, energetic flare of radiation, an accretion flare. Those 7 pixels might not be the surface of a world. They might be the death cry of a comet being shredded by a singularity. The data suppression narrative found in the deep lore of the internet thrives on this specific theory. There is a persistent whisper in the darker corners of the web that NASA and other space agencies are already aware that they are tracking a black hole, but are terrified of the public reaction. A 9th planet is a wonder. A black hole in the solar system is a source of existential dread. The theory suggests that the infrared pulses and anomalies detected by JWST are being kept under a veil of peer-reviewed verification because the implications are too massive for a simple press release. If we confirm a black hole in our own system, it changes everything we know about cosmology. It would prove that primordial black holes exist, potentially solving the mystery of dark matter in one single stroke. We wouldn't just be finding a planet, we would be finding the missing mass of the entire universe, parked just past Neptune. But how do you hunt for a grapefruit in a cathedral of darkness? If it is a black hole, the James Webb Space Telescope isn't the right tool, at least not on its own. To find a singularity, we would need to look for gamma-ray halos or micro-lensing events, where the black hole's gravity acts like a magnifying glass, briefly warping the light of a distant star as it passes in front of it. There are even proposals to send a fleet of tiny laser-propelled light sail probes out to the search zone. These probes wouldn't look for a planet, they would carry ultra-precise atomic clocks. As they flew past the suspected coordinates, the black hole's intense gravity would cause a time dilation effect, a literal slowing of time that the clocks could measure. We would find the hole not by what we see, but by how it bends time itself. The grapefruit in the dark theory turns the search for Planet 9 into a hunt for a shadow. It forces us to confront the idea that the solar system isn't as solid as we thought. We have been looking for a world of ice and rock, something we can understand and map. But the math keeps pointing to something that defies our senses. The invisible shepherd might be the most ancient thing in our system, a relic of the beginning of time that has been silently herding the frozen wanderers of the Kuiper Belt for eons. It sits on its tilted throne, invisible to the eyes of the James Webb, yet felt in the very bones of the solar system's architecture. As we analyze the river of shadows and the constant inward flux of material, the black hole hypothesis adds a layer of cosmic horror. Planet 9 isn't just throwing objects past Neptune, it is a puncture in space that is dragging the outer solar system toward it. It is a capture king that doesn't just want to lead, it wants to consume. If the movement detected in the archives is real, and the James Webb continues to see nothing where a planet should be, we will have to accept the reality of the void. We will have to admit that we are sharing our home with a singularity, a tiny grapefruit-sized tear in the universe that has been watching us from the dark for 4 billion years. The search for Planet 9 has always been a quest to complete our family, to find the missing 9th member. But as we look at the math of the primordial black hole, we realize that the family might have a much darker ancestor than we ever imagined. The 7-pixel ghost may be the light of a feast. The blind giant may be looking at a void it cannot comprehend. And the movement we are tracking might be the final slow-motion approach of our solar system toward a piece of the Big Bang itself. We aren't just looking for a planet. We are looking for the hole where a planet should be, and the deeper we look, the more it feels like the dark is finally starting to look back. Why does the phrase, "it finally moved," resonate with such haunting frequency across the digital landscape? Why do thousands of people stay up until the early hours of the morning, refreshing raw data feeds and scouring uncalibrated infrared frames for a single shifted pixel? To understand the data suppression mythos, we have to understand the fundamental friction between the speed of human curiosity and the agonizingly slow gears of the scientific method. In the age of instant gratification, where we can track a package across the globe in real time, the idea that a massive planet could be found and yet remain unconfirmed feels less like a technical hurdle and more like a conspiracy. This gap, this hollow space between a viral discovery and a peer-reviewed announcement, is where the myth of suppression is born. It is the realization that we may have already seen the most significant object in human history, but because of the rules of the game, no one is allowed to tell us. The suspicion begins with the nature of modern data. In the 1840s, Urbain Le Verrier did his math, Johann Galle pointed his telescope, and Neptune was found in a single night. It was a clean, cinematic victory for the human mind. But today we don't look through eyepieces anymore, we look through data pipelines. When the James Webb Space Telescope captures a deep field image, it isn't just taking a picture of a distant galaxy, it is recording a tidal wave of information, petabytes of raw sensor readings that must be cleaned, calibrated, and filtered through a dozen different algorithms before they even look like an image. This process is a digital purgatory. It can take months, sometimes years, for a single observation to move from a raw burst of data on a NASA server to a public-facing discovery. To the Internet observer, this delay doesn't look like due diligence. It looks like a cover-up. The data suppression narrative is fueled by the 7-pixel ghost from the 1983 IRAS archives. The most common question asked in deep space forums is a simple one. If those pixels were there in 1983, why did it take 40 years to find them? To a scientist, the answer is logical. We didn't have the processing power, the cross-referencing Akari data, or the specific mathematical target zone provided by Brown and Batagen until recently. But to the myth makers, the answer is more sinister. They argue that the archives have always contained the proof, but that the coordinates of Planet 9 were scrubbed or misclassified to prevent a premature discovery. They point to the fact that researchers like Terry Fan and Tomo Goto had to painstakingly whittle down 2 million data points by hand, suggesting that the truth is buried under a mountain of intentional noise. This is where the James Webb Space Telescope enters the mythos as the blind giant. There is a persistent theory that JWST has already captured Planet 9 as a background artifact in a study of something else. Perhaps while looking at the supermassive black hole at the center of our galaxy, Sagittarius A star, or while mapping the G objects in the galactic core. Because Planet 9 is so faint and moves so slowly, it would appear as a stationary, reddish star in any single exposure. The theory suggests that if you were to overlay every single image JWST has ever taken, you would see a trail of ghosts moving across the background of the entire universe. Proponents of the suppression narrative believe that this motion study has already been completed by AI algorithms within NASA, and that the movement has been confirmed, but that the results are being withheld to prevent a global panic about a dark giant entering the inner system. This fear of panic is a central pillar of the suppression lore. The public often conflates Planet 9 with more apocalyptic myths like Nibiru, the hypothetical world that was supposed to collide with Earth in 2012. While Planet 9 is a legitimate scientific hypothesis, with no threat of collision, the data suppression narrative suggests that the authorities are wary of the sociological fallout of confirming a new, massive member of the solar system. They point to the sociology and propaganda mentioned in the transcripts regarding Pluto's discovery. The idea that science is often steered by what the public is ready to hear. If Planet 9 is actually a primordial black hole, as some theories suggest, the suppression narrative becomes even more intense. How do you tell the world that there is a puncture in the fabric of space-time, a grapefruit-sized hole with the mass of 5 Earths drifting on the edge of our home? You don't. You wait until the Legacy Survey of Space and Time at the Vera Rubin Observatory provides a statistical buffer to soften the blow. The friction is further exacerbated by the 5 sigma gold standard. As we've discussed, a 3 sigma result, a good chance, is often wrong, half the time. Scientists like Konstantin Batygin are obsessed with 5 sigma certainty, a 1 in 3.5 million chance of being wrong. But the internet doesn't operate on 5 sigma. It operates on 2.6 sigma, and a good story. When an amateur astronomer on a citizen science project like Zooniverse spots a dim dot that seems to have moved, they want to shout it from the rooftops. When NASA tells them to wait for 3 years of verification, it feels like the gatekeepers are trying to steal the discovery. This has created a citizen science versus institutional science war, where the suppression of information is seen as a way for major universities to maintain their monopoly on the cosmos. We must also consider the River of Shadows flux as a source of suppression lore. If Planet 9 is actively jamming material into the inner solar system, and if we are seeing a spike in interstellar visitors like Oumuamua or the more recent 3I Atlas, the mythos suggests that the government is tracking these movements to predict potential impact threats. The Atlas survey system, designed to detect hazardous asteroids, is seen by some as a Planet 9 early warning system. The fact that the 3I Atlas comet lurched and accelerated in ways that heating models couldn't explain is interpreted not as a chemical anomaly, but as a gravitational reaction to a hidden giant. The suppression narrative argues that the safety and predictability of space took a hit with these visitors, and that the silence surrounding Planet 9's position is a strategic move to keep the public from connecting the dots between the invisible shepherd and the river of debris it is flinging at us. The irony of the data suppression mythos is that the very telescopes that are supposed to find the planet are the ones being accused of hiding it. The Vera Rubin Observatory, which will generate 20 terabytes of data every single night, is viewed with both hope and suspicion. It is seen as the great revealer, but also as the ultimate filter. Proponents of the suppression theory worry that the largest digital camera ever built will be used to catalog everything except the coordinates where the ghost resides. They fear that the Legacy Survey will become a data graveyard, where the image of Planet 9 will be buried under billions of other objects, accessible only to those with the correct clearance to run the search algorithms. In reality, the movement we are tracking is the movement of human knowledge. The reason we haven't found it yet isn't because of a secret cabal at NASA. It's because the universe is unimaginably large and our flashlights are very, very small. But the myth of suppression serves a vital narrative purpose. It provides a villain in a story that would otherwise be about the cold, indifferent math of the void. It turns a search for a planet into a hunt for the truth. It makes the 7-pixel ghost a relic of a hidden past, and the James Webb's blindness a tactical choice. As we look toward the coordinates in the southern sky, we have to recognize that the data suppression narrative is a reflection of our own impatience. We want the Leverrier moment to happen in a tweet. We want the "it finally moved" claim to be the end of the story. But science is a slow, methodical crawl toward the light. The invisible shepherd has been there for 4 billion years. It is not in a hurry to be found. The suppression isn't coming from a government agency, it's coming from the physics of the outer dark. The ghost is hiding behind the inverse fourth power law of light and the staggering volume of a 1,000-fold increase in space. But for those who believe the truth is already out there, the search continues in the raw data. They will continue to watch the blind giant through its straw, waiting for the one night where the data isn't scrubbed, where the algorithm fails to hide the anomaly, and where the 7 pixels from 1983 finally align with a modern frame to reveal the face of the king. They are the watchers on the wall, convinced that the most important map of the solar system has already been drawn. It's just being kept in a drawer until the world is ready to see that the 9 planets of our childhood were never a complete set. The data suppression mythos is the heartbeat of the hunt, a reminder that in the darkness past Neptune, the only thing more dangerous than a missing planet is a found one that no one is talking about. The next step in our investigation takes us away from the data pipelines and into the 2-year countdown, because regardless of what the internet believes, the clock is ticking. A new eye is opening in Chile, and it doesn't care about suppression or myth, it only cares about light. And in the next chapter, we will see how the Vera Rubin Observatory is preparing to either immortalize the ghost or kill it forever. We are entering the final act of the Discovery saga, where the statistics of the Kuiper Belt and the infrared heat of the archives will finally face the ultimate trial by fire. The verdict is coming, and the invisible shepherd is about to have nowhere left to hide. The clock that governs our understanding of the solar system is no longer ticking in the thousands of years it takes for a distant world to complete a single orbit. It is now ticking in months and days. We are currently standing at the threshold of the most significant 2-year window in the history of modern astronomy. For a decade, the Planet 9 hypothesis has survived in a state of scientific limbo, supported by the ironclad logic of mathematics, but starved for a visual confirmation that only a lens can provide. We have seen the fingerprints in the Kuiper Belt. We have tracked the river of shadows pushing material toward Neptune, and we have even glimpsed suspicious infrared ghosts in 40-year-old archives. But the final verdict has been delayed by the sheer crushing scale of the outer dark. That delay is about to end. High in the Atacama Desert of Chile, on a peak known as Cerro Pachon, a technological predator has opened its eye, and it has been designed specifically to hunt down the ghost that has eluded us for eons. The Vera Rubin Observatory is not just another telescope, it is a fundamental shift in how we perceive the universe. While the James Webb Space Telescope is a snipe tool designed to look deep into a tiny patch of space, the Rubin Observatory is a survey machine of unprecedented power. At its heart is the Simony Survey Telescope, featuring an 8.4-meter mirror and the largest digital camera ever constructed by human hands, a 3.2 gigapixel behemoth that is roughly the size of a small car. This camera doesn't just take pictures, it conducts what astronomers call the Legacy Survey of Space and Time, or LSST. Starting in early 2026, this machine began the monumental task of photographing the entire visible southern sky every few nights over and over for 10 straight years. It is effectively taking a 10-year time-lapse movie of the entire universe. And for Planet 9, there is finally nowhere left to hide. The sheer speed of the Rubin Observatory is what makes it the ultimate Planet 9 hunter. In the past, searching for a distant, dim world was a piecemeal effort, with astronomers spending years scanning tiny slivers of the sky with telescopes like Subaru or Pan-STARRS, often missing the target because the planet was simply too faint or moved too slowly to be recognized. But the LSST changes the math of the search entirely. It is so sensitive that it can detect objects as faint as Pluto, even at distances of hundreds of astronomical units, and it generates a staggering 20 terabytes of data every single night. As Mike Brown, the primary architect of the Planet 9 theory, famously remarked, if you gave him $1 billion to build a telescope specifically to find this world, he would simply give the money back because the Vera Rubin Observatory is already the perfect machine for the job. We are now in the middle of a 2-year countdown. The consensus among the scientific community is electric, with a specific kind of tension. Within the first 1 to 2 years of its full operation, the Rubin Observatory will provide a definitive yes or no to the existence of Planet 9. This isn't a vague promise of future discovery. It is a statistical deadline. Because the observatory scans the same patches of sky repeatedly, any object that moves, even with the agonizing slowness of a world 500 units away, will be caught in the act. The digital pipelines of the Rubin will automatically flag any point of light that shifts position relative to the static stars. If the 7-pixel ghost from the infrared archives is real, the Rubin will find it within months. If the planet is hiding in the aphelion of its orbit, at its most distant and dimmest point, the Rubin's unmatched sensitivity will peel back the darkness and reveal its face. But the 2-year countdown isn't just about spotting a single moving dot. Even if the planet itself remains elusive in the first year, the Rubin Observatory will still settle the debate through a process of statistical execution. One of the primary arguments against Planet 9 has always been observational bias, the idea that we only see the clustering of Kuiper Belt objects because that is where we happen to have pointed our telescopes. The Rubin Observatory will destroy this bias forever. It will discover thousands of new trans-Neptunian objects, TNOs, across the entire sky, not just in the target zones predicted by current models. If these thousands of new objects also show the same tilted, clustered, and shepherded orbits, the existence of a massive perturber will move from a 99.6% probability to an absolute mathematical certainty, even before we see a picture of it. Conversely, if the Rubin finds that the rest of the outer solar system is random and chaotic, the Planet 9 hypothesis will die a quiet, data-driven death. This countdown represents the final act of a celestial drama that has spanned over a century. We have moved from the Planet X obsession of Percival Lowell in 1903 to the sophisticated computer simulations of Konstantin Batygin in 2024, and now we have the hardware to match the theory. The search has reached a point where the where is finally as important as the if. As the LSST data begins to flow into the servers at Caltech and around the world, researchers like Batygin are no longer running simulations to see if a planet could exist. They are running them to refine exactly how many nights of Rubin data it will take to confirm the specific inclination of its orbit. They estimate that by 2027, we will have either a confirmed coordinate for a follow-up observation by the James Webb, the Sniper, coming in to finish what the Scout found, or we will have to admit that our understanding of gravity in the outer reaches is fundamentally flawed. The psychological weight of this countdown cannot be understated for the astronomers who have staked their careers on this ghost. For Mike Brown and Konstantin Batygin, the next 24 months are the culmination of a decade of intense scrutiny and professional risk. They are about to enter the Le Verrier moment of their lives, the point where the math either becomes a physical reality or a historical footnote. But even beyond the lead researchers, the entire field of planetary science is holding its breath. The discovery of Planet 9 would be the first time since 1846 that a major planet was added to our solar system through mathematical prediction, effectively completing our family and solving the mystery of the missing super-Earth that seems so common in every other star system but our own. As we wait for the final verdict from the Chilean mountains, we must also acknowledge the Plan B that the Rubin Observatory will inevitably uncover. If Planet 9 doesn't exist as a single massive world, the Rubin will instead reveal the Zitterich-Madigan Belt, a massive coherent disk of thousands of smaller icy bodies, whose collective gravity mimics the effect of a single planet. Or it might find the River of Shadows is actually being driven by something even more exotic, like the primordial black hole that wouldn't reflect light, but would still lens the stars behind it. Either way, the era of not knowing is coming to a definitive close. The blind giant paradox of the James Webb is about to be solved by a survey machine that can see everything at once. The countdown is the bridge between the mystery and the revelation. We are currently living in the last moments of the 8-planet era, a brief period of human history that may soon look as outdated as the time when we thought the Earth was the center of the universe. The "it finally moved" claim, which began as a whisper in the archives and a viral theory on the internet, is about to face the ultimate trial by data. By the end of this 2-year window, the invisible shepherd will either be a named member of our celestial family, complete with its own moons and a confirmed chemical composition, or it will be a ghost that finally vanished when the lights were turned on. The telescopes are ready, the algorithms are running, and the universe is about to give us an answer. The search for Planet 9 is no longer a search, it is a countdown to a collision with the truth. As we stand at the edge of the 2-year countdown, staring into the southern sky with the world's most powerful lenses, we have to confront a final haunting possibility that is perhaps more unsettling than the search itself. What if the discovery isn't a future event? What if we don't need to wait for a new photon of light to hit a sensor in Chile or a golden mirror in deep space? Throughout this journey, we have treated Planet 9 as a missing piece of a puzzle we haven't finished, a ghost we are trying to summon from the darkness. But the most profound lesson from the history of astronomy is that we are often blind, not because of a lack of light, but because of a lack of recognition. The most compelling idea in this entire cosmic detective story isn't what we have yet to discover, it's what might already be hiding in plain sight. To find a planet that doesn't want to be found, we have to understand the star in disguise phenomenon. For as long as humans have looked at the night sky, we have been cataloging stars, tiny, unblinking points of light that seem fixed in the firmament. But history tells us that many of these stars were actually neighbors waiting for us to notice they were moving. When William Herschel discovered Uranus in 1781, he didn't just find a new object. He realized that astronomers had been looking at it for nearly 2,000 years. It was recorded in star charts as far back as 128 BC, always misidentified as a dim, stationary star. Even Neptune, the great triumph of mathematical prediction, was caught on camera by Galileo in 1612. He even noted that the star had strangely shifted position between two different observations, but he lacked the framework to understand what that movement meant. He recorded the greatest discovery of his life twice, and then simply moved on, leaving Neptune to remain a star for another 2 centuries. This is the central anxiety of the modern search. Planet 9 is likely already in our databases. We have photographed vast swathes of the night sky in minute digital detail. Between the Gaia mission, the Pan-STARRS survey, and the Zwicky transient facility, we have billions of data points, a digital library of every photon that has reached Earth in the last decade. Somewhere in those petabytes of data, there is a dim, reddish dot that has been classified as a distant star or a faint brown dwarf. It is sitting on a server right now, waiting for an AI or a human eye to notice that it isn't where it was 10 years ago. The phrase, "it finally moved," is the only thing that can bridge the gap between a dot and a world. In a solar system that is still largely an unknown place, we have fooled ourselves into thinking we know every resident just because we have a lot of data. But the further away you go, the less known it is, and the more room there is to hide almost anything you want. Big planets, small planets, or the rejected core of our own history. This realization transforms the search from a hunt into an act of cosmic reconciliation. We aren't just looking for a new planet to add to the textbooks. We are trying to complete our solar system family. For those who grew up in the era when Pluto was the 9th member of the gang, there is a deep psychological desire to go back up to 9 once more. We have spent the last 20 years feeling like our home was smaller and more empty than it used to be. But the evidence of the invisible shepherd, the river of shadows, and the mass gap suggests that the solar system isn't empty at all. It's just more expansive and mysterious than our childhood mnemonics allowed. We are living in the 8-planet era, but that era is a historical outlier. Most star systems in the galaxy host super-Earths 5 to 10 times the mass of our own. Finding Planet 9 would mean that our system isn't the weird one. It would mean that we finally found the standard outcome of planet formation that we thought we were missing. But what do we call a ghost once it has been caught? If the 2-year countdown ends with a confirmed image, the world will face a naming crisis that has already begun to ignite the internet's imagination. While official naming conventions favor Greek or Roman mythological figures, names like Persephone, the queen of the underworld, or Minerva, the goddess of wisdom, there is a massive grassroots movement to break with tradition. Thousands have signed petitions to name the planet after David Bowie, creating a Bowie mythology where its moons could be called Ziggy Stardust or Starman. It is a fitting tribute to a world that has spent billions of years as a starman waiting in the sky, watching us from the outer dark. Whether it is named after a god or a rock star, the act of naming it will be the final step in bringing it out of the dark ages of our understanding and into the light of the family. As we prepare for the final act of this decade-long celestial drama, we have to look back at those 7 pixels from the 1983 infrared archives. They represent the first time we stopped looking for what we thought a planet should look like and started looking for its heat, its life sign. We moved from visible light, where the planet was 10,000 times fainter than Neptune, to the infrared, where it was only 100 times fainter. We stopped relying on reflected sunlight and started listening for the planet's own thermal whisper. That shift in perspective, the move from seeing to feeling, is the true legacy of the search for Planet 9. It reminded us that the universe is not just a collection of objects to be looked at, but a dynamic, interconnected web of gravity and heat that we are only just beginning to map. If Planet 9 is a primordial black hole, the size of a grapefruit, but with the mass of a world, it will be the ultimate star in disguise. It would be a piece of the Big Bang itself, captured by the Sun 4.5 billion years ago, acting as the silent architect of our system's architecture. If it is a captured king from a distant star, it is our first tangible connection to the rest of the galaxy, an alien world that has lived with us since the beginning. And if it is a rejected core, it is a mirror held up to our own planetary history, a reminder of the violent, chaotic forces that shaped the ground we stand on. The end of the search is truly in sight. Within the next 24 months, the Vera Rubin Observatory will either give us the coordinate that turns the James Webb into a planet profiling machine, or it will prove that the clustering we see is a beautiful mathematical illusion. But regardless of the outcome, the ghost has already changed us. It has forced us to look deeper into the river of shadows, to question the very laws of gravity, and to realize that our solar system is a vast, mostly unknown place where there is enough room to hide almost anything. We started this journey with a claim that spread like wildfire. It finally moved. We have chased that movement through 40 years of archives, billions of miles of space, and the most complex computer simulations ever built. We have moved from a solar system of 8 planets and a void to a system that feels alive with invisible forces and ancient secrets. We aren't just searching for a 9th planet anymore. We are searching for the truth about our home. And as the golden eye of Webb and the giant camera in Chile turn their gaze toward the southern dark, we have to accept that the ghost in the dark has been there all along. It has been watching us from its tilted throne, herding the frozen relics of our past and flinging icy messengers toward our shores for 4 billion years. The search for Planet 9 is not a discovery. It is a recognition. It is the moment we stop being blind to the heat in the dark and finally see the world that has been hiding in plain sight since the day the sun was born. Whether we find a planet of ice and gas, a stolen world from a distant star, or a hole in the universe itself, the solar system will never be the same again. The family is about to get bigger and the dark is about to get a name. The ghost is moving, and this time we are finally ready to follow it.